Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to tackle mole-to-mole stoichiometry. Now don't panic, it sounds much worse than it actually is. Let me show you. Okay, here we go, mole-to-mole stoichiometry. Here is my chemical equation, here is my first question. How many moles of sulfur dioxide will be produced if I have 1.0 moles of sulfur and an excess of oxygen? The first thing that I notice is that I am given moles of sulfur, but I am asked about moles of sulfur dioxide. Whenever I am changing molecules, I am automatically going to be doing stoichiometry, and I need a balanced chemical equation to do that. So let's take a look at our chemical equation. We have sulfur plus oxygen going to sulfur dioxide. Sulfurs are balanced, oxygens are balanced. Great, this is a 1-to-1 ratio. I love these numbers. Okay, so let's put together our math. We were given 1 mole of sulfur. To change between molecules, we are going to use what is called our mole ratio. My mole ratio for this balanced chemical equation is 1-to-1. Both of these ones came from the stoichiometric coefficients in front of both of these molecules. Remember, if nothing is written, it's assumed to be 1. So notice what happens with my units. My moles of sulfur cancel. I'm left with moles of sulfur dioxide. Of course, 1 times 1 divided by 1 is simply 1. And I'm left with my moles of sulfur dioxide in my answer, which is exactly what my question asked for. Let's take a look at my second question. How many moles of oxygen do I need if I want to produce 3.0 moles of sulfur dioxide? Again, I'm asked about moles of oxygen. I am given moles of sulfur dioxide. I need to switch molecules, therefore I know I'm going to do stoichiometry. So for my math, here are my 3.0 moles of sulfur dioxide I was given. To switch molecules, I need to use my mole ratio, which in this case is a beautiful 1-to-1. Notice my moles of sulfur dioxide go in the denominator, so they cancel. Here are my moles of oxygen. So my answer is simply 3.0 moles of oxygen. Unfortunately, not every chemical equation balances out to be a 1-to-1. Let's take a look at a problem where we have a different mole ratio. My question asks how many molecules of sulfur trioxide are produced if 6.75 moles of sulfur dioxide are reacted with an excess of oxygen. Again, I am given sulfur dioxide, I am asked about sulfur trioxide, so I know I need to do stoichiometry, which means I need a balanced chemical equation. If I look at the chemical equation that was given to me, I can very easily see, no, this is not balanced, so let's balance it. Now I can move on to my math. So I am starting with what I was given, my 6.75 moles of sulfur dioxide. I am first going to convert that to moles of sulfur trioxide using my mole ratio. Now notice my mole ratio uses my stoichiometric coefficients from my balanced chemical equation. These 2's came from these 2's up here. My moles of sulfur dioxide cancel, and I am left with moles of sulfur trioxide. Okay, this is great. I have now switched to the compound that the question asked me about. However, my question asked me for molecules, not for moles, which is what I have right now. So I need to add one more step. I need to convert from moles of sulfur trioxide to molecules of sulfur trioxide. I need Avogadro's number. So here is Avogadro's number. Notice my moles of sulfur trioxide cancel. Now I have molecules of sulfur trioxide. I just need to plug and chug into my calculator. Here is what my calculator gives me. Of course, with the correct number of sig figs, my answer is 4.06 times 10 to the 24th molecules of sulfur trioxide. Congratulations, you have mastered the first step in stoichiometric calculations. And because stoichiometry is always going to go through moles at some point, this is a very important foundational skill to have in all stoichiometric calculations. Now in my next video, we are going to tackle those pesky grams. So I hope to see you there.